The Grand Prismatic Spring, a colorful, boiling pool that does the impossible. So, what exactly does this mean? Let's talk about it. To explain what's going on here and what I mean by the impossible, let's start by talking a little more about water. The boiling point of water is right at 212 degrees Fahrenheit, which is the same as 100 degrees Celsius. Now, an interesting fact about boiling water is that this 212 degrees really only applies if you are at sea level. It changes based on your elevation, so if you're high up in the mountains, for instance, like in Colorado, the boiling point is going to be a lower temperature. But if you're below sea level, somewhere like the Dead Sea, then the boiling point is going to be raised up to a higher level. Yellowstone National Park sits at an average of 8,000 feet above sea level. So, as you can guess now, the boiling point there will be slightly lower. Now, when water boils, a critical thing happens. It turns from a liquid to a gas. When water is heated to its boiling point, this extreme heat causes the bonds that are holding the water molecules together to break. This breaking of the bonds sends water into its gaseous state, aka steam. In other words, once water begins to boil, it turns into steam and goes up into the air on its merry way into the atmosphere. Now, this is important to know because here's the thing about liquid water. It can't get any hotter than boiling, because as soon as it does and it starts boiling, the liquid turns into steam and then it pieces out of whatever container it's in. So if you're cooking some pasta, the water in your pot is going to turn into steam and just, go into the atmosphere and do whatever it is water does in the atmosphere. A lot, actually. That's a whole topic for a different video. Anyway, the point here is that water can't get any hotter than boiling, except for in places like Yellowstone. The liquid water in Yellowstone's pools reaches temperatures above 400 degrees Fahrenheit. That is nearly double what it should be. So, how on earth is this happening? Well, first off, we have an extreme source of heat. The heat that makes Yellowstone's pools bubble and boil are actually due to a massive supervolcano sitting beneath the surface, which is really cool. And if you're wondering just how hot this volcano is, I'll say this. The Earth's mantle ranges from between 2,000 and 660 degrees, and the supervolcano exists because there is a crack in the Earth's crust which exposes the heat of the mantle to the surface. So, it's hot. This volcano hasn't erupted for over 600,000 years, but when it did, it covered nearly 6,000 square miles with ash. So yeah, this volcano is massive. But perhaps what is just as, if not more important than the supervolcano heating the water up to over 400 degrees, is the thing that's keeping the water from evaporating once it gets hot enough. And this thing is pressure. The Grand Prismatic Spring is 160 feet deep. In other words, the crack in the earth that's letting the heat from the volcano escape is 160 feet below the water's surface. This pool is also about 300 feet wide, so it holds a lot of water. And a lot of water means a lot of pressure for whatever is sitting at the bottom. As water sits at the bottom of the spring getting superheated from the volcano, the pressure and weight from all the surrounding water keeps it from turning into a gas. As a result, the liquid water is heated well above boiling temperature. Eventually, though, this water has had enough and needs to come to the surface. In the case of the Grand Prismatic Spring, the superheated water is actually less dense than the cooler surrounding water, so a current is created, which helps the water make its way to the surface. So that's how Yellowstone does the impossible in one way, but the next way that we're going to talk about is what I think is the most fascinating. Alright, so we've established that these pools are really, really hot, and obviously this makes them pretty dangerous. All around the park are signs warning visitors to stay far away from these pools because contact with the water is known to be deadly. So then, what if I told you that these scalding pools were actually full of life? And that there is a direct relationship between the life here and the striking colors of Grand Prismatic Spring. I mean, I thought it was pretty cool, so. We've established that at its hottest, the water in the spring gets up to 400 degrees, but obviously the entire pool is not that hot. That 400 degrees is mainly right by where that crack in the mantle is that allows all the heat to escape. That's the hottest part of the water. But when you come up to the surface, you see a whole range of temperatures as the water gradually cools more and more. Interestingly, we can determine how hot the water is based on the colors that we see. The blue direct center is hottest, around 189 degrees Fahrenheit. Next to the blue is the yellow ring, which is around 165 degrees. Then we have the orange ring, a cool 149 degrees. And finally, the red color at the edges at a comparably chilly 131 degrees. Now, obviously, these temperatures are not suited to fostering life, but somehow, life has found a way to survive here. And not just survive, but absolutely thrive. The Grand Prismatic Pool is absolutely filled with microorganisms that have evolved over time to call these 100+ degree waters their home. These microorganisms are called thermophiles, which means heat-loving organisms. And they're microscopic, but when billions and billions of them live together in one place, we're able to see them. And how do we see them? Well, they are exactly what we're looking at when we see the colors of Yellowstone's pools. All these organisms create these colorful mats that lay over the Grand Prismatic Spring and many other thermal features that you find in Yellowstone. In other words, the colorful bands that you see are actually billions and billions of colorful microorganisms like bacteria. And what's even more interesting is that different species of microorganisms prefer different temperature ranges, even though they all like the heat. For example, one species of bacteria that happens to be orange prefers to live at temperatures between 140 and 155 degrees Fahrenheit. In contrast, the yellow bacteria likes it hotter, from 153 to 167 degrees. And as beautiful as they are, and they are striking, these colors aren't just for show either. In fact, for many of these bacteria, the colors are actually pigments that help them conduct photosynthesis. These bacteria have been heavily studied, and they've even been the secrets behind huge scientific advancements, including one that you are almost definitely familiar with. Do you remember those PCR tests that we all had to get during COVID? We got them from Yellowstone. PCR stands for polymerase chain reaction, and to simplify things, it's a scientific process that was invented from studying Yellowstone's bacteria. PCR technology isn't just used for infectious diseases either, though. It's also used in crime scene investigation, cancer research, and detecting genetic diseases as well. But the scientific discovery doesn't stop there. We are continuing to study these bacteria because we think they might even hold some clues into the origins of life itself. Which, I don't think you can get more intense and cool and important than that. Like, that's a big deal, right? Who would have guessed that Yellowstone's colors meant so much, and that these colors are the result of these little bacteria doing what we would think is the impossible? Hang on though, because we might think we have it all figured out, but there's one more twist here. The blue color we see is completely different. It's not at all from bacteria. In fact, we think that it is so hot in this blue area that even thermophile organisms can't survive. So the blue color doesn't come from some awesome species of blue bacteria, it actually comes from the water itself. So you know how the ocean water looks blue? This is because light interacts with deep water like this in such a way that it makes it appear blue. It's a bit of an optical illusion, and it is exactly what's happening in Grand Prismatic Spring as well. That being said, we aren't entirely convinced that there aren't any microorganisms living in this blue area of the pools. We know that there are some thermophiles that are able to withstand temperatures this hot. We just haven't found any yet, so the search goes on. It's also important to note that these thermophiles don't just live in Grand Prismatic Spring. I just used it because it is an iconic example. But in fact, there are different types of thermophiles that live all over Yellowstone. Depending on the water temperature and the water's chemistry, like if it contains iron, what its acidity is, etc., different microorganisms will live there. Additionally, I use the term microorganism and not just bacteria because there are actually a lot more than bacteria thriving in Yellowstone's heat. Different species of fungi, algae, and protozoa also make up the population of thermophiles in the park. So all of that is pretty cool, and to me it seems like Yellowstone does the impossible. But as fascinating as all of this is, we certainly can't talk about Yellowstone without talking about the massive, incredible supervolcano that's sitting just beneath the surface. So if you want to learn the story of how this volcano came to be, as well as when is the next eruption going to be sure to check out my other video on Yellowstone right here. Thank you so much for watching, and I will see you in the next one.